thank you all again for joining this 30 Years of Globe webinar. Comparing data past and present is our campaign theme for the year, and I'm really excited about today's talk by Peder Nelson, who is the Globe Observer Land Cover Science Lead, and also co-leading an intensive observation period that's happening right now called the Snowview Intensive Observation Period, which I have a feeling he's going to talk about. So without further ado, I will turn it over to Peder, who's going to be talking about making our visual stories talk, making our data talk. So thank you, Peder, for joining us so early from Alaska. We really appreciate you doing this for us.
Yeah, definitely. Thank you, Allison, for getting everything arranged and everybody who's joining us. And you're right, Allison, it is 6 a.m. up here in Alaska. And I just happened to look over at my phone and get reminded that I'm in a different time zone. Uh, I just kind of want to recognize, like, this is half the fun of our global community is that everybody's doing things at different times in different places and over the 30 years, right? And that I think is a really wonderful piece that I've yet to find anywhere else in the world around a program that has managed to be so influential and to be part of really trying to track something that is hard to do individually. Okay, and that is why I really like satellite data, and that's one reason why I keep coming back to it and putting it in front of everybody's faces, whether you really know what you're looking at or not. And so, with that, I want to really kind of highlight one of the things that I've done for my career is really looking at the past and trying to understand how did we get to today. And so, as you've seen in many of my other presentations, Landsat is really my tool for being able to do that. And that satellite record is what allows us to really get our data to talk to each other, and really helps us to understand our own experience. Maybe we made some measurements and we have some numbers, but really it's our own experience in the world that has been happening around us and is recorded in this memory of the world. So with that, I want to take us over and start talking a little bit about, again, one of my favorite things. And so, this is something that I feel is a really good place to start. Just asking questions, just starting to, look at what was happening when you were in second grade in school, and weren't looking at the world, weren't part of the globe community, or at least out making measurements like so many people really like us to do. But what I want to stress is we have this ability to look back in time. And you've most likely seen something like this at some point over the last 5 years, because the technology has gotten a lot better and a lot easier for all of us to access the satellite data and this record of memory. And so one of the things that the lab I work in and have worked in, we have really spent a lot of time trying to make animations like this, or trying to separate out and be able to understand how do we actually see change, not just every image that comes through. We really want to focus on what's underneath the clouds. And I know I'll get pushback from cloud people, but right now I want to get rid of all of those clouds. And that is one of the big barriers that we see when we try to look back over time. We have obstructions, usually atmosphere, or clouds or things like that, that actually make your imagery look different. And this is one of those things. All right, I'll go there. Allison, thank you for introducing our intensive observation period, because that is one reason why we care so much about making up photos, or why we take down photos, is because we really are trying to make this animation, like you're seeing here, be true to life. And atmosphere is one of the most complex and challenging things, especially when you look at 40 years of satellite record. We have a lot of things that are happening, and one of the pieces that really is both good and also challenging is things like smoke. or fires or things that are actually happening on the ground that also obscure or get into the atmosphere. So again, one of the things about these animations is that one, they can be pretty to look at. That's one thing. Two, they can convey a lot of information really fast, almost too fast. Okay. And you can see here with this animation of a location, we are seeing a year every half second. It is going so fast that you can see the big changes that are happening here. Like, looks like land development. Actually, we're getting some greening going on. Um, but this to me is one of these challenges that animations make. Okay, so I just kind of want to stress that as one of these things where this is a great tool, but it can also really be overwhelming. And so one of the things that scientists like me, remote sensing sensors have done and developed to do is this thing called dwell time. It is looking at an image for a long period of time and trying to see where all the changes are. What is happening there? And this requires patience, as I heard from our European phenology campaign. Practicing patience is actually a really good skill, regardless of your age. And so this to me is one of these pieces that we can play with in terms of how fast we make these images change over time. Okay, and again, this is something that allows us to play with dwell time, actually being able to look at an image. Okay, and here I want to really stress that we're looking at a relatively small area. 10 kilometers is the largest that we've sort of programmed in to make this animation. And that's purposeful, because it takes a lot of data to actually make this, because we are working at the Landsat 30-meter pixel resolution. Okay. And that's also what makes this nice, is that you can zoom in at the scale that you're actually making your globe observations. And so, this is a tool that actually came out in 2018. And it is based off of, like I said, all the work that we do here. So I want to stress that you can go here and find this. Allison, if it hasn't been added yet, let's see, I will drop this into the chat, so that you all can actually go and visit this NASA Landsat page where you can make your own animation. Okay, so with that, what I want to show you is, let's just walk through the steps that are here, right? We're using Google's Earth Engine to access our satellite data. This is kind of a key thing, because Earth Engine is really just a catalog. It's like going to the library, really, because they're making copies of the NASA data that is stored in the primary places, like the land processing DAC, LP DAC, and so this is one thing to just kind of recognize, is that you can use Landsat data or access satellite data in a lot of different places, but be aware of documenting that, or aware of what might be happening in that software or that hardware, or that way of accessing it. Okay, so I just kind of want to stress that, Google Earth Engine is really powerful, and this is one of the things that we've been able to do with it. So again, we'll go there. The next thing that is really important, is actually we get to choose what is the date range that we're looking at. And importantly, we have the ability to go all the way back to 1984. Doesn't mean that you actually have one in the location you're looking at, but it allows us to go back to the beginning of the 30-meter Landsat record. Okay, and so that's really important, because that is the consistency, that allows us to actually see the same things and make our animation real. Um, and then you get to choose the end year. And so again, one of the things that we found useful is to make blocks of time. You might do decades. You might do certain periods of time that you have your data, that you've gone out and actually done something, made some measurements on the ground. Importantly, we get to actually choose the month that we're going to focus on here. That is a really important variable when we start thinking about time, and especially time, not just in 1 year, but over many years. Okay, and so this is one thing that if you're focused on what happens in the summer, that is why we've sort of focused here, because you can see the vegetation change or forest change. But again, depending on what you are researching, I found that this is actually really useful to change. So we'll play around with that and see what happens when we change that variable. One of the other great things about multispectral imagery is that we get to make different colors, and we get to make the Earth change colors. It's really this magic piece that we do, and it's because we are measuring the electromagnetic spectrum. Right. And so, I will highlight a great resource for that, the tour of the electromagnetic spectrum. But recognize that this is this superpower of teaming up with a satellite, is that it actually can see things that we can't, even through all of those, or around the clouds that I went on about earlier. But this is something that is beyond what I'm going to present today, but is something that we have a lot of resources and is really a good investigation. What the heck are all of these different ways of seeing multispectral imagery? And so we'll look at some of those when we go to the tool and talk about that a little bit. The final thing is that it actually, this process goes actually to Google's Earth Engine and does some of the processing there. So we're actually using, as I've heard it described to me, YouTube video hardware to actually do our processing. So I think that's kind of an interesting thing to think about, the hardware, the software, the data, and you making some of these choices to get an interesting result that you could share with all the rest of us. Okay, and then there's some little additional pieces that help to add context, and so we've had some updates to this as well, software changes. So I highly recommend looking at the updates at the bottom. There's two other tutorials here to kind of go a little bit deeper. One of the more flexible and updates to this way of doing this, it was built by a colleague of mine, Dr. Qixing Wu, and so you can see a demonstration there of how he's doing exactly the same thing. And so again, this is the wonderful thing about science, is that usually there's more than one way to get to the same place, to the same answer. Okay, so with that, I just want to pause and open it up and ask, is there any questions that we have here before we just go dive into making our own animations? Let me go down. All right. And thank you, Rusty. Thank you for being here. I appreciate the comments inside of there. So one of the things that I do want to start off with, how many people out there know their latitude and longitude? If you do, or you're interested in looking at a particular coordinate, put that into the chat so that I can know that, I can see that, and I can use that as an example. But this to me is one of these pieces that we really want to work on as a globe community, is really getting to know not just the geographic name of where we're located, like me, Anchorage, Alaska right now. We really, when we start working with computers, we really need to turn those into numbers. So one of the things that you'll see me start referring to is numbers related to the place. Thank you, Barbie. That's exactly what I was looking for. And I'll highlight, Barbie she contributed in our chat here the way of actually putting in our latitude longitudes. And here I'm just going to grab that out of there. Um, and so this is something that we'll talk a little bit about, because this is actually a challenge with the Globe database that I've had, and something we need to check on sometimes is our coordinates. Where are we in the world? Do we have a negative sign, or do we have a positive sign? So again, take a moment here and put those in here, because that's one of the reasons why we're here. It's not just for me to talk and to show off all the fun things and ways that I see the world, but if you share with us your latitude, longitude, you can actually put that in here, and we'll talk about your location as well. Okay, so one of the things that you might wonder about, like, okay, so I don't know where in the world I actually want to where I'm my coordinates. That was the word I was looking for. So what I'm going to do is I am going to first start off by just going to the Globe Viz site. This is a place. It's not the best place. It is a place to get coordinates. And it's also related to maybe some of the numbers that you have collected in the past, the ones that you've measured. Okay, so I'm just going to go in here, and one of the things that hopefully should show up is if we go in here, we can actually turn on our map grid, right? And one of the things that will show up is our mouse latitude, longitude. So you can use this as a way of getting those numbers, okay? Again, one of the things I want to really stress here, zoom in. Don't just look at this map and try to approximate where, like Larissa is. Where's Boston, Massachusetts? Well, I kind of know it's over in this area, and I could put my coordinates right there. But my locations here is about 1 degree off from what Larissa put into the chat there. So this is something that I really, really want to stress, is that these numbers become more meaningful and accurately represent what you measure by zooming in on our maps, by using actually as many decimal points as we can. Right, and so this is all in that GPS guide that we've talked about, and that Globe has. So again, I really want to stress this, because when we talk about data over time, this is the piece that I'll say walks and isn't always exactly in the same place. And so for our purposes today, um, we may not need to get as exact as we do when we make our globe observer measurements or our globe measurements, but just recognize these numbers are really, really important to making your data talk in a meaningful way, and especially when it starts having a conversation with other data, right? So this is me personifying this. And so we'll go back here to our page that gives us our instructions. Now that people have their locations, and everybody, thank you, Larissa, as well for dropping that in there. And what I'm going to do is going to go to this Earth Engine app. One thing that I want to kind of stress here and show is that you can see who is getting credit or who has built this by the beginning of their name right here. So this is coming from our lab, the eMapper lab. And as a Globe partner, this is our focus and has been. So if you have any questions about satellite data or how to work with this or what to do, reach out to us as a Globe partner, because we can help guide you through some of this. And one of the things that I want to highlight here is this idea of zoom levels. This is very similar to scale on a map, on a paper map, okay? But it's something that, again, helps us to understand how much data we're actually seeing at that moment in time. Okay, so this is me having a lot of fun. One of the things, too, that I need to preface this, we're looking at a map that has no clouds. That's very, very important, because it is not true world. It is a mosaic, as it's called, a mosaic of the world over many years. And so just recognize that you're looking at a composite, very similar to what we'll end up making here. But just recognize that when you're looking at these base maps, that they can lie to you, they can mislead you, and they can represent moments in time that are hard to deduce. Okay, so that's a really important thing as you are start looking at this. I'm going to start off and just zoom into one of my favorite areas, and I'm just going to zoom in here to Southern Oregon because this is really where I've spent most of my time looking at pixels. One of the things that hopefully you'll notice when you zoom in on this location is the variety of colors. Okay, so this is something that we'll get into when we look at how we want to colorize our satellite data. Here, you're looking at a natural color image, just like you take with your globe observer data. It is a blue, green, red representation of the world. Okay, and what I mean by blue, green, red, those are wavelengths coming from the sun, right? And so one of the things that as we zoom in, we can start to um, think that the green things are vegetation. Okay, that makes a lot of sense based off of what I know, based off of what my phone is telling me when I make my globe observer observations, and that is something that's really important here. So I'm just going to continue zooming in here to a particular location. Let's see. And so we have Ashland right there, and I'm going to zoom in on, and you can see, when you zoom in, you get details that weren't visible before. The other thing is, look, all of a sudden, what I was just saying about colors, um, we can throw out the window because we actually have clouds here in this image, and this is something that happens. Right. And this actually is the exact example to Allison's point. We're focusing on snow right now within the globe community. And why? Because as you can see here, identifying snow versus cloud is one of our remote sensing challenges. And so here, this is what we are trying to do right now. And this is a great example of the variability that can happen in a high resolution image. Okay. And so, this is, again, one of these things that it would be wonderful if we had data at this resolution, at this level, to be able to see the individual trees like this. But what we're going to show today doesn't have that. As many people refer to them as blurry pictures. They're the moderate resolution. And so again, it's nice to be able to zoom in and get this sort of resolution, but for our purposes, we'll be kind of focused in about this area. Okay, and so to do this, what I first need to do is actually just click on this location on the map, and I will not do that. Actually, I will go over here and get rid of this chat because my screen is just not quite big enough. Okay, and so we're going to start off with 1984 as we go through this. We're going to define our years, 1984 to, I'm actually going to take it back to the end of 1995 so that we can start and look at what happened before the GLOW program existed, right? I'm going to stick with this date range just because it's a good one to start off with, and then we will go over and I'm going to stick with our red, green, and blue. Again, that red, green, blue is something that you'll see with satellite data a lot. Whenever you see red, green, blue, that is the same as our natural color, as what we call it, or as what you take with your globe observer photos, red, green, blue. Okay, and so things should look sort of natural there. And so now um, I am looking at going in and actually putting in some points. Like, where do I actually want to make this animation? And so the way that Justin has programmed it up is that you go in and you put in four squares or some points, and it will figure out a square or rectangle for you. And if you once you do that, it will automatically kind of do the geometry, and it will start sending this information back to the Google server to actually start working with. Um, and so, right now, like, I don't really see anything, right? Like, what's happening? And so that can actually happen. So give it a little bit of time sometimes for it to run. The larger area that it takes, the more challenging that it is to actually, get all the pixels over time, and all of those kinds of things, right? So this takes a little bit of time to go through and do. Again, one of the things that I want to stress here is this center point of our longitude and latitude. And that's why I ask everybody to get that, right? Is because that helps us to one, make sure that this is what we actually want. And then the second thing is that it helps us to do kind of this next thing, which could be adding context, and a map and some of those additional pieces, um, here by following this little link. And that's described down below about this. And so again, one of the challenges of working in the cloud, and not having your data right next to you, is that it can take time to get anything done. I'm sitting up here using my bandwidth talking to you all, and so that could actually be causing some of this delay that we're seeing right here. Okay, so while that cooks, what I want to do is I'm going to take you over to our lab website, our Globe Partnership page, not the Slack page, because you guys don't need to see all of our wonderful internal messages, right? But actually our lab webpage. So when you go to our eMapper webpage, you'll see me and all the wonderful things that I do. Apparently, I'm pointing up a lot these days. But here is where you can actually find out a little bit more and access a similar tool, but with a little bit more details. And so here again, one of the things that we're talking about is how to make your data talk. And so one of the things that we again are trying to do is help you access that. So I'm going to go here to this LTGEE animator, and you'll see it looks exactly the same, right? But one of the things that I will highlight is that Google has been changing things. And so you'll see that even the beginning here is slightly different, because of the computers on the back end. So again, this is one of these things that for me makes data talking really challenging, is just this piece right here, trying to access it, trying to make it work, trying to do what we need to, right? So I just kind of want to keep stressing that piece because learning how to talk with a computer and deal with the fact that these things change underneath us makes the animations and just kind of doing this work a little bit challenging sometimes. Okay, so I am now what I want to do is we got that one running in the background. Hopefully, yep, it's just kind of sitting away doing its little thing, right? And so here, what I'm going to do is I'm going to go over to Boston, because Larissa was so nice to give us a location. But I'm going to come over here to the Boston area and just kind of zoom in and go through and do kind of the exact same thing that I did before. I'm going to zoom in more because again, we just need to really get in kind of close here. But I'm just going to go in and try to do a box again, just to kind of get us anything, right? To have a discussion about. Um, all right, let's see. Will it close? All right. So while that is happening, what I would like everybody here to do, because like I'm on a delay, I'd love everybody to go and go to one of these tools, either to our eMapper website and go to this one, or to the one off of the Landsat page. Try to make your own animation, and go through and find an area and try to do this. And I'll give everybody a five minutes or so, and you'll see me over here waiting to see if we can get any data, right? And I want to see if anybody else is faster. Maybe your internet will get us there a little bit faster. Um, but I want to make sure everybody here gets a chance to make their own animation of their location today. And that will also reveal any questions that might be lurking out there. So I'm going to just pause right here. I was successful. And so I'm going to pause right here and give everybody a moment and drop into the chat, or do what Larissa's been doing to me this whole time, which I really like, is give me a thumbs up or some way that you know, or that I know that you've done something, that you've participated in this. So if you need that link again, I'll put this into the chat for anybody who has come up kind of recently. Oh, it looks like it was there. That's great. Thank you, Allison. You are doing the best one. And to the point about, is there a best browser to use? Well, since it is Google Earth Engine, Chrome browser tends to be the best one. You know, Google makes it. Google likes to work within their projects, and so the way that works tends to work a little bit better. But you should be able to use any browser to do that. That's and yes, John, either link should work. Should take you to the same type of tool to be able to do the same thing. So again, that's one of those things about Google's Earth Engine is they really allow users to be able to copy code. And yes, Allison, you should be able to see the animation on the side when it actually shows up, just like what is happening here with me. Um, and so we'll talk about what is happening there, but you should actually see exactly this, the same kind of thing where underneath the width, the centroid, where I currently was just sitting on my other animation, we now see over Boston area, we have something, okay? And we'll talk about what that something is because it's very interesting. But right now, like this other tool is just sitting here, not really doing anything. So quite honestly, right now, I'm wondering whether this code is still working because I'm not getting anything off of this one. So if you have that experience, again, let us know, you know, because it is the same code in the background. But again, the hardware is getting manipulated and things get changed in the background from us. Again, cloud computing, it's wonderful until you're trying to rely on it for real-time work, right? Uh, so that's great. Okay, so I see, you know, there's questions about browsers. That's kind of like the main thing. And yes, wonderful. A great suggestion actually was to get your coordinates is on your device. If you have your mobile device, you can you might have a compass app, and if you pull up your compass app, not only do you get to learn which way is north, but it will tell you your location as well. So, Robin, thank you very much for that wonderful suggestion. Okay, I'm going to sit here, give everybody a chance to do what you wanted to. Okay, Robin, if you wanted to see the same single month year after year, yes, you can change the month. Okay, and so in that case, you would come in here and hide that thumbnail, and you would change your start date. Again, you know, we kind of did this automatically because summer months are usually kind of the time that we focus in on. But if you wanted to see just like the month of June, you could go in and you could do something like that. And only 30 days, right? uh, and so, but one thing to recognize is that the shorter the date range here is that you will get less imagery because again, we're working with Landsat, which the Landsat satellite series, which goes over your location only every 16 days. Luckily, we now have a couple satellites that are working together up there. And so we've been able to reduce that down to 8 days. Um, but that's actually one of the exciting things about Landsat Next is that that would get us down to anywhere from a 2 to 3 day repeat coverage. And so these animations are just going to look so much better because this delay in repeat observations is a challenge, but it's what allows us to actually see the things on the ground. And so, there's a trade-off always between resolution and repeating your observation at your location, which again is why we're doing this intensive observation period and having you go out and fill in the gaps when like Landsat's not going to be back for 16 days, or at least one of them. And so what's going to happen in between that time period? And that's part of why, actually doing exactly what Robin was mentioning, if you focus in on a particular date range like this, you'll get to see the gaps because you won't have any data. And so you'll see a black screen or something like that for that particular year, that month within that year. Um, and Barbie, Barbie's having problems here. Thank you for putting that into the chat that, it shows that it's generating and then you get nothing. Okay, if that happens, it really could be an internet delay. Your bandwidth may be slow, and so it might just be taking a long time for these things to be generated on the servers where they are in a physical space, but then actually getting them transferred to wherever you are. And I know, being up here in Alaska, we're really far away. And from the servers in Oregon, actually, where some of these are. And so, yeah, so, that lag time can cause problems. John, thank you for highlighting again, you're experiencing the same thing. Yes. Some things that can happen is too many people going to Google's Earth Engine at the same time actually can cause it to slow down. So so this is again one of these challenges of working globally is that if people in Switzerland are really like wanting to know what's happening and they go to Google's Earth Engine, they can actually, cause it to um, process all of their data first. And then we have to get in queue in the line and we have to wait for us to get processed. So again, this is one of these opportunities. If the world isn't concerned and working at the same time you are, you might be able to do things really, really fast. If you end up working at the same time other people are, you can really end up hitting these bottlenecks like this, like what a lot of people are experiencing here. So, if you come back a little bit later, maybe if we don't have 20 people all trying to do it, it will work. You know, but this is definitely to me, as an educator, as a researcher, as a human alive at this moment in time using these tools, um, this is something that I've learned I have to deal with. And I also have to help my supervisors understand what is happening, and why I'm having the delay, because most likely they don't know what is happening or what is going on. They have assigned us this task. So one of the things that I see what happened on the side here, and this is research in action. Allison just let us know that the one off of our lab website, this eMapper website that I'm showing right now, the one I got to work, is the one that she got to work as well. So that's really disappointing to me, because this is I think one of these challenges that we have within the Globe community. I'll just really stress this: with 30 years of um, lessons, of methods, of ways of doing things, they get out of date. And so how can we as a community actually alert each other to examples like this? And so we need to now let Landsat or the NASA folks know that we need to update this page. Okay, so just be aware that that's one of those things that you might encounter when you are working with satellite data, whether it's on a NASA webpage, a NASA tool, or some of these that are getting developed by other people. Okay, so thank you, Allison, for guiding everybody to the one that seems to be working. Again, the way that this is described here is exactly the same as what you use on that tool. And so one of the things that John asked about that I didn't go into, but one of the things that you see when you make your animation is that it's just the pixels. It actually doesn't have a scale bar. It doesn't have the years of related to that imagery. So again, this is one of these things that images can just be images. But if you add context, like the date and the scale, you now have meaning. And so this that was the thing that we actually had to create. And the person who created this, Justin Broughton, initially he had to go to a different software package outside of Google Earth Engine, and that is what this Make It Snazzy is all about. This tool has you upload your animation, your file, and then provide it some information about well, what was the time frame that you made your animation? What was this? What was the scale of the box that you made? Where are you located in the world? Um, with that information, you're actually able to make this snazzy animation, which provides to me, meaning that has always been missed actually with a lot of the animations that have been made in the past. Okay, so that is what that Make It Snazzy is all about, and you'll see that's actually using a different software package called R. Um, so again, this is one of these fun challenges of working with satellite data, is figuring out how to talk to the data. What is the translation that you might need? And that is what the software is all about. So anyway, that is the process of how you can make your satellite data talk, right? And so I'm going to go back to this one because I want to stress a couple little things here that um, you want to play around with. Okay, so one is this, how many frames per second? You can think about this, how many years do you want to see per second, right? If we went all the way up to 30 frames per second, you would basically have an animation of 1 second. It would just show you the imagery, and it would go so fast that I don't think I could interpret it. But there might be some value there. And if you're able to keep repeating this, that might actually really show something, really fast in terms of those big changes. But again, that might emphasize certain things, and you don't really know for your location until you actually do it. Okay, so this is that research piece: is you've searched, come up with something. Now we want to research and do a little bit of variable translation. If you take this all the way down to 1 frame per second, you will have a 30-second animation, or that will show you a year every second. That might actually help with that dwell time, but it takes 30 seconds to get through all of 30 years, or 40 seconds to get through 40 years, which is closer to what we have. So if you have 40 years of data, can somebody sit there for 40 seconds and look and see those changes? We'll go through them. So I recommend, try making your animations really slow or really fast. Or, again, think about this, the frames per second is how many years per second do you want to be seeing this? Um, and I highly recommend try going through and just looking at what happens when you choose these different color combinations, these different wavelengths of measurement that we're seeing here. You may not know what they are. Well, reach out. I can tell you what the heck this TCB, TCG, TCW is, but right now, I'm not going to. I would like you to experiment with that. We have some descriptions about what those are actually on our lab webpage. So, Allison, thank you for pointing everybody to our Globe partnership page there, because that is a place where you can find out a little bit more about these ways of seeing the Earth. Okay, and it's ones that we'll come back to and talk a little bit about. There's also some other globe materials related to land cover in particular that talk about multispectral measurements and how your trees go from being green to being red, um, all in how you display them on the computer. So these are, to me, kind of the wonderful ways that you can start to explore your location, your study location over time. If you are having problems and you can't get this to work, send an email to Allison. I'll put her on the spot here. She, as helping us arrange all of these things. Send a note to Allison and or reach out to us at Globe in some way to help you to get this animation, because once you get it made, then comes the interpretation. And that really is where your local knowledge helps to reveal or helps to understand and explain to the rest of us what is happening there. Okay, so I since we were able to get this animation going on the side over here. Larissa, thank you so much for just at least giving us a place to look. One of the things that I want to highlight as we're going through is you can see these little white objects that are like popping up inside of there. Those are actually rooftops of buildings. So we're starting to see big convention centers or big warehouses or other big white buildings starting to come in like that. One of the things that happens right off the bat with this is actually a bunch of clouds. And that's why you just see this really random pattern right at the beginning of this animation. And then we can actually start to see the rivers, which are black in this color combination. We can see the green parks that are around. I even like this lagoon and or meadow or lake that we can see right down here at the bottom. But the fact that we actually have clouds during this time frame early on, or at some point, that is a really important piece of information that might help us to understand why we measured so much water in our globe measurements that year. So make it snazzy. Um, really add the years to this, add the scale bar. And you can also, by right mouse clicking on this and doing the save image as, you then can download that and you can just share it out. You can put it out there. As long as something can read this animation GIF format, you can actually see this time series going on. Again, without having a year, this is useful, but it is not really very useful, right? Because what year did this occur? When does the beginning of our animation happen? I don't even know right now, right? And so you're seeing changes, you're seeing some information, but it is definitely not to the level that we can use it. And that's where the snazzy piece really comes in. And so you'll see I have put on my Globe website, various versions of this. And I'm going to just like save this. And I will put this onto my desktop. And I'm going to just save that right there. And what I'm going to do is see if I can. Yep. So when I just open that and go and open it, it opens up in my preview software, the software that you can use to look at any image. And it's only showing me the very first image inside of there. And so just kind of be aware that you actually have a stack of satellite images with this. And you can actually go through some of your software packages, your imagery packages, and start to extract them out. And so when I actually just opened this up on my Mac computer, I can actually see that the first 2-3 years are really cloudy during this time frame, during this summer time frame. Again, why is that? Why did that happen in the 1980s, but we didn't have the same thing happen later on? That is the beginning of where these animations really start to give us science questions, right? So again, with that, we want to go back and start looking at all of the data that might be in our location at that spot. Make sure to, use the data counts. Look across the time span. Again, we won't have any data in this database before 1995. But afterwards, if you zoom in and you really focus in on your location and make your animation snazzy, you will be able to start providing that context. And so that to me is the really exciting piece of starting to move from the historical ground measurements that we have in the globe database to this ability to start going through time, right? And I will take us to, a final place where you can actually do this with all kinds of NASA data. You can see that time series with Landsat is really valuable because we can go all the way back to 1984. One of the things that is happening in the background that you don't even know about is we are actually standardizing and trying to get rid of the noise that happens from the atmosphere, that piece that I was really lamenting about earlier today. One of the things that when you make an animation here with uncorrected data is that you will actually start to see changes that are happening, false changes, as we call them, right? And so one of the things is just kind of be aware of that. And so if you see other Landsat animations, think about how they're actually getting their data. How are they making it work from one year to the next year? We have spent 25 years working on that problem. And so we are uniquely qualified to help you think about your particular ecology, your particular location. And to that point, one of the things here that we were sort of focused on, right, is snow. So this is our world today, and we don't have our view of the world in North America, but here is our world yesterday, right? And to the point that Allison brought up, are all of these clouds, or is actually some of this snow on the ground? Is white always white? And right here, we're looking at that natural color image, or true color, as it's called here, right? And one of the cool things is you can actually set up your own animation here. Again, how many frames per second? You can do year increments, just like what we were doing before. And you can go back and make an animation for, say, the last 5 years. And this will use Google's things. This is an example of, another way that you can make an animation of satellite imagery. Because of this data, its coarse, the resolution that we're at, notice we're out at 1,000 kilometers, it doesn't look as good as what we were looking at. But if you want to look at what it was like literally the last year at this time, this is one way of doing that. And I will end today by kind of walking back a little bit in time so that we can see this animation go through. And last year, this is what it was. Um, and so, like, very interesting, right? An animation can help us see processes that a single image doesn't. So that's what we were trying to achieve today. That's what we were trying to share with you today. And I want to seriously end here with this, with showing you the data that we are trying to understand. And that is this snow cover data. And this is on a daily basis. Okay, so what I'm going to end with today is asking you to go out and make some observations and help us to understand whether these are really clouds or whether we are actually really seeing snow over time. And here I'm going to go up and take us to the last little bit of time and change this from so for the last, let's say, last 11 days or so, this has been the snow cover, the snow extent. So again, I really recommend slowing down your animations so that you can see what is happening with this. But I really hope that you are inspired by this ability to look at a place over time, whatever time frame you want, to help see patterns that are not possible in one image. And make your own. Share with us what you are finding, what you are doing. And as I've been seeing in the chat, please, reach out to us. We are very able and happy and excited to bring this to you, your community, your students, and help really connect the satellite data to what you're doing on the ground. So thank you very much for coming to what we're doing today. And as Allison put into our chat, go out and make some snow observations and join us for that Snow View IOP. We are very excited to keep exploring this way of looking at satellite data that helps us to put 30 years of globe data into context, whether it be daily context, monthly context, or yearly context, or even decadal context. That is what we're here to do right now. So I am very excited to start my day off. It's still dark here in Alaska, but we've got a whole environmental education workshop going today where we'll be sharing out what we're doing. And thank you for all for letting me start my day off talking about something I care so passionately about. And thank you all.